But there's another mechanism in which chemicals that we get exposed to, and these could be chemicals like BPA in plastic water bottles, or it could be heavy metals like mercury from amalgams, or whatever the source is. But we get exposed to chemicals, and our chemicals, the percentage of them bind to our tissue proteins. And we have blood, in our blood, we have a protein called albumin. It's actually the most abundant protein in our blood, and it's there to, as a protein regulator, osmotic pressure. So we have no leakage of fluids and so forth, and the right pressure in our blood vessels. But chemicals can bind to albumin, and then albumin can change its structure, and it becomes a new protein. And we call it a neoantigen in immunology. And then the neoantigen can then trigger the immune response. So that's like the immunological model. So it's not all, and the immunological model isn't based on about the toxic load, because everyone's like, how much mercury do you have? How much pesticides do you have? Let's measure the quantity, and that's a valid model. There's nothing wrong with that. There's definitely that mechanism for autoimmunity, but there's another mechanism. This is where my PhD work was in with the help of Dr. Rishta Vijani, but we showed that chemicals can bind to proteins change the structure, proteins that change the structure can then lead to autoimmunity. And then we linked many different autoimmune diseases with this chemical binding process in several papers we published. But that's the other component, and that has to do with what's called immune tolerance. Now, immune tolerance means whether you react to the environment, and there's three different types of tolerances. There is self-tolerance, which is really what autoimmunity is. Autoimmunity, you lose self-tolerance, so immune system start to attack you. And then there's dietary protein tolerance, also known as oral tolerance. And that's when you start to develop food sensitivities and you start to react to more foods. And then there's loss of chemical tolerance. That's when you start to have reactions, immunological reaction against chemicals. So when you lose one, you lose the other. So it's very likely that if you have an autoimmune disease, you have some degree of loss of not only self-tolerance, but dietary protein tolerance and chemical tolerance. And why this is so important is because trace levels of chemicals can trigger the immune response, even though they're not going to show high levels on a quantitative test. And the only way those are evaluated would be by looking at chemicals bound to protein antibodies. Like Cyrix has a test where they do chemical immune reactivity, where you can see chemical antibody reactions with these proteins. And I'm on the disclosure, I'm on the scientific advisory board for the Cyrix, but the test itself is looking at the immunological component of the immune response. So that's important, because sometimes we get so fixated on the level, and especially for autoimmunity, the level may not always matter. It's whether the person starts to develop immune reactivity to it.